Yep.
To upload it to YouTube. So yes, please turn off your camera if you're not comfortable with this. So yeah, welcome to today's Arborist Call. It's the 2nd of May, and I'm Pili from the Zcash Foundation hosting today's call. The agenda for today's meeting will start with some updates from the ECC and Zcash Foundation co-development teams. Then we'll have some updates on research and implementation work. We will then open the floor to participants for any announcements that may be of interest to the community. And then we will jump into a discussion on network upgrade planning, I believe with a focus on the Sustainability Fund proposal. And finally, if there's any time left over at the end, we can cover any other open discussion topics. So what is the Arborist Call? The Arborist Call is a bi-weekly call where the Zcash protocol contributors meet to discuss upgrade timelines and process, protocol research and development efforts, design and implementation of new protocol features, and we identify blockers and unresolved issues. And the purpose of this call is to try and make Zcash protocol development accessible to everyone that is interested and to provide more transparency to the community. Anyone can register to attend. You can just go to zcasharborist.org. And if you want to become more involved and present during this call, you can email us at arboristcall@zfm.org, and we will provide you with a presentation slot. Outside of the Arborist Call, you can participate in the Zcash community in a number of other ways. You can apply to one of the grant programs. You can take part in community discussions either in the Zcash R&D Discord or the Zcash community forum. And there are clickable links for all of these at zcasharborist.org. So with all that, we can move on to today's agenda. We'll start with an update on Zebra, which is Zcash Foundation's node implementation. Aria, are you delivering this today?
Yep. Thank you, Pili. So since the last Arborist Call, we've restored Windows support in Zebra by publishing a new version of Zcash script and updating Zebra's dependencies, added more fields to testnet parameters like disable proof of work, network name, Genesis hash, made other changes to support regtest with NU5, like calculating the median time passed and the difficulty limit for short chains, skipping the slow start interval, and skipping checking if Zebra is close to the tip before returning block templates. A minimal version of regtest is now working on the params regtest branch, which will hopefully merge soon. We're almost ready to publish a new release, and it should be included there. And we've also fixed a minor concurrency bug in the Z get tree state RPC method and increased the end of support time.
How long did you increase the end of support time to?
I can't remember exactly.
Okay, I'm just asking because it might be relevant to timing of NU6. I mean, presumably it's not excessively long, but we will need to know what it is.
I think we increased it from 16 weeks to 20 weeks.
Okay.
Yep. I also have a quick question about median time span. How do you calculate that when you are below 17 blocks in the chain?
I believe that is well specified in the spec. Let me just go and look it up.
Okay.
Yeah, it's well specified in that we figured out how to specify the thing the Bitcoin core code just happened to do.
Yes.
Which I believe is just it does the median of the shorter range of blocks. Like the code that looks it up just looks back to Genesis.
Hang on. Well, don't wait for me, but I'll look it up.
We can probably take that one offline and just.
That sounds good. Thank you.
Cool. Any other questions for Aria? Okay. So next, we have the.
I have it now actually. Median. Okay, so when median is applied to a sequence of even length, the element that begins the second half of the sequence is taken. It's in 773.
Okay.
Thank you, Arina. I think we can go to the updates from the Electric Coin Company on Sashi and the wallet SDKs. who can tell us something about that today?
Andrea, can you do Zashi?
I don't think she's here.
Oh, she's not here. Crystal Strata?
Yep. I mean, the big news there is obviously that the Android Zashi 1.0 release has gone out, and we've started. We've gotten, I think, I don't know the exact numbers, but close to, or perhaps over 1,000 installs at this point.
It was 1,600, I think.
Okay. So of course, with a bunch of new users, we now have a few new bugs to look into. That the most important ones are ones that are in the common wallet backend code base. So we're currently working on triage of a couple of issues there. We also have been making forward progress on specification work with Arya's help for potential NU6 memo changes, and have also been working out some additional issues related to ZIP 315, which are essentially standards for wallet developers and recommended best practices for wallet developers. So yeah, a bunch of wallet and a bit of protocol functionality related work going forward.
Yeah, there's also some ongoing work in the vein of continual refactoring of the Rust crates. So in the previous couple of breaking release changes, we did some refactoring of the sapling code, which was released earlier this year. In the last couple of weeks, we've been doing some work to decouple the like sprout, sapling, and orchard and transparent parts of the functionality in the crates from themselves, in particular to enable downstreams who only want to, for example, create transactions with one aspect of these can remove the rest of the dependencies out of their stack. This will also then be beneficial for both enabling the upcoming transparent functionality that is required for a Zcash wallet replacement to be potentially separated from wallets that don't need it, that's purely shielded wallets, and also should hopefully ease future pathways towards deprecating pools. If we have better ways for wallets to migrate away from supporting the older tech in their stacks. So there are hopefully the top level transaction type change can be kept away, but some of the transaction creation pieces underneath are going to have some fun new states they can represent. Yeah, and then I think everything else has just been going on and is just minor internal engineering work. Yeah.
Great. Thank you, Strat. Any questions for Strat or Chris? So next up, we actually have a joint update from ECC and ZF on Zcash deprecation. Who can give us an update from the ECC side, and then maybe we can fill in the gaps from the ZF side.
Well, on the bits that I'm aware of, we have continued to fill out the graph of things that need doing. We've had some discussions around the wallet architecture and getting some consistency on what the functional aspects of the replacement architecture need to be. And then, as mentioned in the previous section, there's been some initial engineering work towards enabling the changes that need to be made to be for adding missing functionality to be added. I've also been resurrecting my scripts from 2020. I ran them in 2019 and 2020 for analyzing the distribution of P2SH scripts on the network. And I am rehabilitating those to make them runnable again. Because apparently when you don't touch a script for 4 years, it bit rots. Who knew? And so to start on collecting more of the data that we need to feed into what things need implementing on the transparent side.
Okay, thank you, Stuart.
Yeah, I put a link to the Zcash deprecation DAG in the chat. And the other thing I remember was that we made a start on re-reviewing Sean's PR, where he had made a start on sort of transliterating the Bitcoin script interpreter into Rust.
Yeah, so that is 1362, issue 1362 on the DAG, which may end up, if that can end up in a viable place, then that may end up being what we replace. Well, it may subsume the current contents of the Zcash script crate, for instance, which currently is C++ based.
It's not strictly necessary, but it would be nice.
Yeah, and in the beginning, it would at least make sense. The thing that that's going to be looked at there is doing not necessarily full-on fuzzing, but at least like prop test based comparisons between what the Rust code is doing and what the existing C++ wrapped Zcash script crate expects. So being able to provide incremental improvements to pin down the behavior that we expect from the transparent scripting backend.
Yes. Like I say, not a blocker for Zcash deprecation, because we can continue to use Zcash script in Zebra, but it's really nice to have that functionality in Rust, so that we can use it in the Zcash wallet replacement work.
And for some of it, it may end up being necessary. That's still to be determined.
Great, thank you. Alfredo, do you have anything to add from the Foundation side?
Yeah, so our plan is, in the short term, in the Zebra side, is to move the Zebra scan crate we have inside Zebra to a separated repo. Yes, we wanted to do that after we upgrade the dependencies we have with the ECC libraries. That's becoming a bit harder than we expected. So we're not sure if we will move now or we'll move after we sort it out. Yeah, we will probably get started with that after CCOM-B. The idea is to put the scanner functionality in a separated place, and we are doing that planning with Strad and the other ECC engineers to figure out if the indexer that we have to do needs to be inside that crate or in Zebra itself. But yeah, we don't know yet. We don't have enough details yet. I guess we will have more information in the next coming weeks. Thank you for the Zcash script, the research and getting started on that. I think it's going to be very useful. Yeah, I'm really glad that this started the work in that.
You're welcome.
Thank you, Alfredo. If there's nothing else, we can move to the research and implementation updates. Okay, so we have Zcash shielded assets up next.
That's me. Thanks, Billy. So yeah, this time we'll start with zips, which like I haven't had an update on that in a while. But like we did spot that we had not included the burn digest as part of the transaction ID digest and Zcash computation in our zips. So we added that in, and we like made sure that that's the same thing in the implementation as well. So that's been like one change in the zips that has happened like beyond just minor typographical changes. And yeah, we haven't opened a new pull request since the time that the older pull request was merged into and like is available on the zips website of Zcash. So we'll open a new pull request in the coming days to have a track of and have comments on things that come up.
And
Yeah,
when
we
you
expect
noticed that, did you check all of the other potentially affecting data to make sure that was also included in the hash?
Yeah, I
Okay.
should be. I think we've covered it, but yeah.
Okay.
So yeah, that's for the zips. The other thing that we've been working on is backward compatibility recently. We've, I think, largely finished most of the work for the Orchard and Libra Zcash backward compatibility bits. So like Orchard is largely making sure that we can build the two different, the vanilla Orchard and the Orchard ZSA bundles simultaneously. And I think in Libra Zcash, it's mostly being able to handle V6 transactions. The part that's left is largely test vectors, and I think some of the Orchard vanilla tests that were there, like we have to bring them back in and make sure those are working as well. So those are what we are working on now. When it comes to test vectors, we did some refactoring of the test vectors repo as well, because there was like a lot of room for code reuse between what we've changed for ZSA and what already was there. So yeah, we've done that, and we've tried to like clearly separate what we have added on in separate folders and stuff. So it should hopefully be easy to review when the time comes for that. We've been working on Halo 2, and I think we've been having discussions with ECC pretty regularly, figuring out what generalizations, like the generalizations that we've made, do we include it in Halo 2? Are they like specific to the Orchard circuit, and should we have it like basically keep it in Halo 2 or like make it specific to Orchard and things like that? So that's in progress, not as far along as the Orchard and Libra Zcash work. Yeah, we've also begun to get cracking on starting a testnet for ZSAs. So that's like pretty recent news. So we've, I think, only just got around to like setting up a Zebra node on an ECS instance and connecting to it locally and things like that. So it's a good first step, but there's the whole like making sure it works with ZSA that's yet to come. But yeah, stay tuned, and hopefully in our next update we'll have more to say on that. And yeah, finally we have ZCon V next week. I see a number of nice backgrounds on some people's Zoom, so I have it on my foreground instead because I got the t-shirt. It's nice. So yeah, at like we at Kedit, we'll be diving a bit more into all these updates and talking a little bit about the asset swaps design over there. So looking forward to interacting with everyone there.
Great, thank you, Vivek. Exciting news about testnet. So let us know if we can help out in any way with that. Does anyone else have any questions for Vivek? Okay, let's move on then to Frost. Natalie, is that you giving the first update today?
Hello. Yeah, so Conrado and I have just been what's what I'm looking for? Preparing for ZCon V. We're giving a talk on Thursday, like first thing, because time zones, the beginning of the conference. If anyone wants to come to that. So we'll be giving like sort of, yeah, we'll be giving updates on you know, a lot of stuff you'll have heard in here anyway. So we're currently working on the refresh share functionality, which will mean that if you can remove a signer without sort of like having to yeah, like change your address basically. And so we're about to do a release of version 2. We have some breaking changes due to like some Rust compiler changes, and we're adding the no STD flag, which is going to be on by default. And yeah, I don't know how much like people know about that change. Oh yeah, Dyra. You're muted.
Removing a signer without changing the public key. Let me think about that. So the so it's not that you have to specify which signers you've removed when verifying. It's just that the other signers that or potential signers that you haven't removed refresh all of their keys, and then you can sign either using K of M with the old keys, but some of those have been deleted, so you assume that that can't happen, or with K of N of the new signers. Is that right?
Well, you have to, so you redo the key generation. So however you want to
Right,
do.
but because the public key hasn't changed, it must be the case that the K of N with the old keys still works, right?
Yeah, Conrado, that's correct, right?
Yeah, that's correct. It still works, but the idea is that maybe one participant was compromised or lost their share, and then you can refresh the shares. So yes, it's true that K of N of the old shares will keep working. But if someone has only one or something less than K, then they won't be able to use it.
Yeah.
So
Okay.
that's the
Yeah,
idea.
if the
So
if the
it's not,
old
go on.
if the old set of signers, if you're doing the rotation because someone lost access, then it's really just recovering that. I think the case for removal is more if a previous entity is determined to be malicious, then as long as at least T of the honest signers have deleted their older versions, then there's no way for them to
doesn't it have to be N minus T minus 1 have deleted? So that
well, okay, so
you
K.
only have T minus 1 left.
Well, K, yes. So the you need, yeah, you need a sufficient number of honor. I think it's actually K minus.
It's N minus T plus 1 must have deleted in order for there to only be T minus 1 left.
When we're not changing the threshold.
Right. Yeah.
Exactly. So it's the point is that rotation is fine because the old set can't be used if enough of the honest signers honestly rotated and deleted their old data.
Okay. Yeah. Just clarifying the security model there.
Sorry, just answering Dodger's question, you could change the threshold. That's not that's something we've sort of spoken about, that's being suggested in an issue that someone raised, but it's not something which that's not part of this. It's not part of the refreshing the shares.
Yeah, it can be done, but it's a bit more complicated. So we're just doing the easy thing first, but eventually we could support changing the threshold too.
Yeah, that's the sort of thing that would be useful in like a context where you're moving from, say, 3 of 5 to doubling the number of signers, 3 of 10, you don't want.
Yeah, I mean, arguably you should have a mechanism for key rotation anyway, and then that mechanism will also apply to Frost keys, Frost group keys.
Yeah, I don't think there are any other updates, Conrado, that I've missed.
I don't think so. We're still waiting for the draft to be accepted by NIST. But other than that, Paco asked if you're trying to document the use cases. Yeah, Yeah, if you feel there's something missing in the book, we hope the book is as complete as possible. So there's something missing. I think part of this refreshers is also documenting. So yes, but yeah, I think that's it.
Thank you, Natalie. And I would add that if there's any documentation missing, please raise an issue, and then we know what we need to do. Thank you. Anything else on first? Okay, let's move on to trailing finality. Darren, I start you.
Yes, I am busy finishing off my presentation for which is on, I believe, Monday of ZCon 5, so I only have a few days left, but it's going well. Yeah, fortunately, there's a previous presentation that I can grab from, but yeah, it will be different from that. Yep, looking forward to it. And as part of doing that, that will involve, I don't know whether I'll have this done by ZCon, but if not, then soon after, updating the TFL book for Crosslink 2. Yeah, so basically just specification work. There's been no implementation work on TFL.
Thank you, Darina. Any questions? Oops, 1 second. Open announcements. Anyone have any announcements they would like to deliver?
Yeah, I got one.
Go on.
I want your opinion on this. I'm about to send it to people. Oh, can I share my screen?
Yeah.
Yeah, go ahead. I think let me know if you can't take over.
Oh, well, never mind. I'll just say it out loud. So the announcement is the same that I've been announcing a bunch before, which is that at the end of this month, on May 22, 23, 24, we're all gathering together for ZK Proof 6. This year there's something special because there's the choosing of the verified verifier. There's going to be a kickoff to do formal verification of one particular verifier. It could be Groth 16, it could be Bulletproof, could be Plonk, could be something else. And there's a whole conversation that's going to happen there to figure out the pros and cons of blessing a particular verifier and focusing security attention and speccing on one particular one over the next 12 months. And other than that, there's going to be actually Jens Groth, Alessandro Chiesa, and Costas from the circuit giving keynotes. So it's interesting for those people that are into zero knowledge proofs, and I think it's going to be a great follow-up for ZCon V.
Yeah,
Costas from Mistin
hopefully
Labs,
I
think.
will be there.
Just to...
Sorry, go ahead. You clashed in the audio.
I said hopefully I will be there. I've yet to work out travel, but probably.
Oh, amazing, amazing.
Go on.
Yeah, I was just saying that I think to add to John's, Costas is like from Mistin Labs was the specific information that was missing.
Yeah, Costas Chalkas, he used to be in Facebook. Now he's in an ecosystem called Sui. I gave a demo here about ZK Send, ZK Login, which uses Groth16. That's part of their work. It's very inspiring stuff, and I think there's a lot that can be brought back to the Zcash ecosystem to like accelerate what we're doing here. That's my announcement. I'm very consistent, right? I think I've been saying that for a while.
Great, thank you, John. And of course, CCon V is next week. I'm assuming everyone here has registered, but please do register if you haven't done so already. Please ask lots of questions ahead of time for I think all sessions. I think that will really help the moderators and presenters. Great, I think any other open announcements? Okay, let's crack on then, because this next portion might be quite a long discussion, and this is on network upgrade planning, and in particular with a focus on the Zcash Sustainability Fund. Do we have anyone to kick us off on this topic?
I don't think there's anybody from Equilibrium on the call, actually. No. So I don't know if anybody from ECC, I know ECC folks have been collaborating on this. I don't know if there's any.
I mean, like we said before, we have been working on the memo changes back. And we did discuss to some extent the ZSF.
The ZSF discussions were earlier. That was mostly zip editor discussions, not ECC discussions.
Yes, that's right.
Yeah. And so, we've not discussed it in the last week or so. So if Equilibrium isn't here, then we can't fill in that regard.
Got that.
Okay. So maybe no discussion on the Zcash Sustainability Fund today.
Yeah.
Yeah, we will need to get a move on figuring out exactly which things are going to be in E6, because the roadmap says that it's that needs to be decided now.
Yeah. In the meantime, if we want to, we could replace this with a quick overview of the memo work that we did in the last couple of weeks.
Yeah, that sounds good.
Which we mentioned earlier, just to get wider, because it is at the point now where the requirements things are basically is what we've figured out, and we have a sketch of the design, and the next step after this will be actually like nailing down what the specification is. But if people have comments on the overall design, now's the time for that to be done. So if that's what,
can you sort of give a brief summary?
Yeah, I can do that. And if there's I can even just screen share the I can't share while someone else is sharing.
Oh, let me take care of that. Try again.
Okay, yep, that's allowed it. Okay, can you see that?
Not yet.
No.
Just wait until you tell me.
I still see the old screen share, so maybe that's not.
Maybe if I stop sharing.
Yeah.
That will let
okay, now it says I'm screen sharing. Okay. So as has been mentioned in prior calls, we've now essentially got the motivation down here, but in short, the combination of the fact that right now, as part of the shielded protocol, the addresses of senders are not revealed to recipients in any formal way in the protocol. Senders can stick their return address into a memo field, but it's completely unauthenticated and they could put whatever they wanted in there. So for recipients who want to authenticate who the sender is, there is currently no way for them to do that in band, because the functionality that we would need to build for authenticated reply addresses can't fit into a single memo. There's also, we've noted here that currently the way that the light client protocol works is sending a truncated ciphertext down, cutting off the memo to save pieces there, but that complicates the security argument for the light client case, and switching to pulling the memos out from that would simplify, and it would actually simplify the way the implementation works there as well. So the requirements that we've enumerated after a fair bit of discussion about this here, the primary requirement is that recipients can receive memo data greater than 512 bytes. So 512 bytes of text gets replaced by some variable length thing. Multiple recipients across any of the shielded pools can be given the capability to view the same memo data. So if you, so like right now, for example, YWallet, in certain transactions that it creates, it will create an output in both the sapling and orchard pools, and it will just copy paste the same memo into both outputs, which has actually come up in the initial Zashi launch, where people have been noticing duplicate memo data in the Zashi UI. So right now, there's no way in the backend to detect that those are actually meant to be semantically the same memo, because while weird, there are edge cases where you can imagine that seeing the same memo text twice actually has different semantic meaning than seeing it once. This requirement basically would mean that if you are actually wanting to show the same memo for multiple outputs, that gets encoded into the transaction structure. And then the privacy requirement, where the exact number and exact length of distinct memos should not be revealed, even to the transaction recipients. So if I am able to decrypt one or more of the outputs of a transaction, I can learn the memos that those outputs were given the capability to see. But whatever of the rest of the information I can't decrypt, I should not be able to learn anything more than what is revealed by like the amount of data that is left unencryptable, the amount of data that is left that I can't decrypt. A recipient should be able to determine whether or not they have been given the capability to view a memo solely by decrypting the note ciphertext. So this gets back to that light client case. We've had this problem for a while where you can't tell just by downloading that truncated ciphertext whether or not you received a memo, so you have to go get the full transaction to enhance it to get those memos. If we're making this change here, the idea is that you just encode that in a mechanism into the key, so then you can tell by decrypting the full note ciphertext if there's anything in the memo for you. And again, learning that is that just saves on downloading and decrypting that data. And then finally, the final requirement we settled on was that memo chunks, so like the memo is split, will be split into a series of chunked pieces as part of a multi-memo decryption and arity hiding things, but they should be individually prunable without preventing the transaction from being verified. And so what I mean by this is, you verify a transaction is included in the chain by deriving the transaction's TXID, the ID of the transaction, and you can prove that a TXID is included in a block by showing a Merkle tree path to the block. And so this is really just a constraint on the way in which the memo data is authenticated within the TXID, in that it should be possible to replace a memo chunk with the commitment to that chunk, so you can still derive the TXIDs, but be able to prune that data. And then just a non-requirement of, we don't need to be able to receive multiple memos per note, per output note, because you can, a recipient who wants to do that and send multiple memos to a single receiver can emulate that by just creating dummy notes. Okay, and then I'll skip over the spec, the initial sort of sketch of the spec for now, because this is the stuff that still needs to be figured out and changed. But the main rationale that we've included in here basically is around, that we've had here is for why we want to include a pruned, like make sure that the encoding is prunable. Doesn't necessarily mean that they will be broadcast on the network in pruned form, but this is more about if a node operator is presented with a memo decryption key, which gives them the capability to decrypt and view a memo, and they don't want to store that data, knowing it's there, they have the ability to prune it from their local store without needing to do that. And likewise, if if the memo data gets, as has been seen with, for example, in Bitcoin, op return based null data storage on Bitcoin. There was a problem a number of years ago where some people were using that to embed virus detector signatures. It's causing antivirus software to detect the entire Bitcoin blockchain as a virus and delete it, or delete individual block files. And the way that Bitcoin Core fixed that was by XORing a random salt value in with all the block data on disk. So that the data was still there because it couldn't be pruned from the disk, but it was just hiding the signature from the antivirus software. This is sort of a defensive mechanism here from that kind of potential like chain abuse from adversaries, where if that kind of thing occurs, nodes are able to adapt to that locally without compromising the ability for those nodes to still enable wallets to decrypt data. So it makes the memo portion of it still authenticated, and obviously if you gain access to memo data via some other pathway, you can then verify that it's correctly for that transaction. But it gives you the ability to prune where necessary. And in particular, there's a note here about it doesn't introduce the ability to prune the data is just an artifact of the way that it's authenticated. It doesn't provide any additional censorship access for a global adversary, because assuming that we meet this requirement of we don't leak anything about like the number and length of distinct decryptable memos, then there's nothing in for an entity that doesn't have access to a capability to decrypt a memo, there's nothing in the transaction memo section that they can use as a censorship vector, like a distinguisher for that transaction. And the transactions themselves, fully shielded transactions, similarly are designed to lack those distinguishers. So you can only do that pruning, you can only sensibly do the pruning if you have already not the capability to decrypt it and view it, is the rationale for that.
Dodger asked about implications for transaction size.
So the implication on transaction size is, this gets a little bit into the specification, but the rough idea that we've still got to pin down is that instead of having a single AAD ciphertext which contained, so normally in a transaction, for each note output, you have a single AAD containing the note plaintext, which is the things to derive the address, the amount, the randomness that goes into the note. And in the case of ZSAs or post ZSA upgrade, there'll also be an asset-based value that goes into that note plaintext. So that's all necessary data in the output already. And then in addition, there's a 512-byte field for the memos. So all up, you have the size of the note plaintext, which is necessary per output, plus the memo data, plus the 16-byte tag, which is the overhead you get from an AAD ciphertext. And so the 512-byte part of that per note ciphertext will get replaced with a 32-byte memo key, or something along those lines, but to be specified, but around about 32 bytes. So reduction per output from 512 to 32. But then there's also going to be, with ZSAs, an increase of 32 for each note anyway. And then in the memo side, you're then the memo data that would have gone per output is now in the memo section, and each of those memo chunks, because we represent the memo bundle as a vector of memo chunks, each of those will have an authenticated encryption overhead as well. So you could imagine one possible memo bundle as being, we have as many memo chunks as there are outputs in the shielded outputs in the transaction. And that would be, for example, if you actually wanted to send, like the same as before, a 512-byte memo to every output individually. And that would essentially amount to a 16-byte, 48-byte, because the 32-byte keys plus the 16-byte tag, it would amount to 48 bytes of overhead per output in the transaction data size. But that's an upper bound on that, because the memo bundle lets you then reduce that at the cost of revealing certain things about arity. but there's a trade-off you can then make there in terms of privacy versus the amount of data you put in. And you could, for example, just have a single memo chunk, which still is large enough to store the same amount of data if you wanted to, but identifiably a single chunk and therefore a single memo. And then you're only paying 32 bytes per output for the keys plus one 16-byte overhead for the whole transaction at the other end of the scale. So it's about the minimum overhead that we can do while maintaining the security level we want. You could make an argument that we could use 16-byte symmetric keys instead, and certain encryption formats do. 32-byte keys make it simple. We don't have to care about Grover ever becoming viable, for instance, in a quantum computer setting.
I'm actually more worried about multi-target attacks and low probability attacks against without quantum computers. So,
yeah, and that's something
that's why we use 256-bit crypto values throughout the protocol. There's a paper by Dan Bernstein called "Understanding Brute Force," which gives the rationale for that, really.
Yeah. And there may be other things that get, when we write the actual specification, they get folded into this. Like, for example, we currently rely on CHA 20 Poly 1305 for AED encryption, and that is not key committing. So you can run into multi-target attacks there as well from that perspective. So there might be, given that we're defining a new AED here section, we might make changes there, but this is in the to be specified part. Functionally, what this zip proposes is just a separate memo bundle section with a vector of chunks. And then you decrypt your note outputs as normal, you get a key, and if the key indicates that it is a real key, like you can decrypt with it, you can then go to these memo bundle chunks and decrypt a subset of those chunks, like say with key A here, and then concatenate those chunks of whatever length they are to get your final memo. Cool. Any questions? Any thoughts on requirements? Any thoughts on impact? Or sound good? Cool. All right.
Okay, thank you. Let me share my screen again. If I can get oh, there we go.
Just checking the chat. I see, yeah, the note about ZIP 317. Yes, the way that fees are done would account for this, and indeed, you would then essentially be, because you now have independent arity, like length data visible publicly for both the individual note outputs and the memo data, you account for those separately in ZIP 317 fees. So you might have a lower fee per shielded output and then pay fee for memo data.
So just as kind of a fun aside to this, so after we've been talking about it, something that I've been considering is that ordinals on the Bitcoin chain are have been I don't know if a driver of adoption, but a popular thing there. This will, I have an idea for a shielded ordinals protocol using the memo data that could be, given that we'll have the separation of memo keys from memo data, there's a pretty straightforward approach to an ordinal-like functionality that combines so in the presence of an extended memo, one of the things that we'll want to change is to make more use of I think it's ZIP 302. Am I thinking of the right one? Anyway, structured memo data, such that you can have multi-part memo data that is where all the parts of a memo are related to one another. And so given that, one could have a specification for an ordinal inscription that would include the ordinal data and then the prior step in the chain of verifiable reply to address that could give you the sort of conventional chain of custody like you have with ordinals.
So I know that on Bitcoin, the way that ordinal NFTs are currently done depends on SegWit and Taproot. I don't know what the exact, so the SegWit part, probably we've already done the necessary things for that in zip 143 and 243. But the Taproot part, I have no idea how they use that or why.
So I mean, my understanding is perhaps too shallow, but I understand it as essentially you establish a chain of custody for a trivial output with a given op return, and we can establish a chain of custody via authenticated reply tos and publicly
or payment disclosures
or payment disclosures of some sort.
Yeah, the thing it relies on in Bitcoin is the visible transaction graph, which is precisely the thing that we don't make visible here. So
yeah, so you would need payment disclosures, I think.
Yeah, you would essentially need to payment disclosure, but a payment disclosure is something that can fit in a multi-part memo along with your payload. So
yeah, and this is also this is something that would be relevant to for others to think about for the for zip231 for the memo changes is there was an idea from way back. I think I opened an issue about it on the Zcash repo in 2017 about like more granular payment disclosure. So right now, the concept of a payment disclosure is just disclosing, like essentially disclosing the OCK value for a particular output, which reveals the amount, the recipient, and the memo data for a given recipient. And you could imagine the key structure being derived in such a way that you can reveal subsections of that data. Currently, with the direction we're currently hitting, the 231 for this memo proposal, being able to decrypt the note by definition lets you decrypt the memo, but you could then give out the capability to decrypt the memo in a transaction without having the capability to decrypt the note that like essentially the capability to decrypt a memo on chain is being sent in band, but it doesn't have to be, and essentially it becomes just an this essentially becomes enabling Zcash to be an arbitrary permanent data store, which is why we have the ability to prune things as a requirement. But the rationale then is like you could also imagine a structure where you are providing multiple memo components that logically tie together into the same logical thing like ordinals or whatever, but where all you're revealing is the bit that's necessary to be public. So you only reveal the memo key that contains the willing part, and then the private part is sent to the same recipients in a different note, for instance.
Yes.
Yeah. But if there are other use cases or other ideas around things that could be done with partially public data for shielded, in particular things that people currently use transparent for, this is a line of thought in the direction of deprecating transparent. Like replicating transparent functionality in shielded world, or things that people need to be able to do, is along these lines. And so we obviously don't want to do everything at once here, but if there's something that is easy to do, enabling that in that direction while we're separating out memos anyway, it would be worth thinking about.
Yeah, something has occurred to me, which is that so Kedit has suggested using verifiable encryption for compliance purposes for stablecoins optionally. And if we have arbitrary length memos essentially, then that's no longer that can no longer be accommodated by the proof associated with an output. So you would have to have if the memo was long enough, you would have to have additional proofs to cover it for the verifiable encryption, I think.
Yeah,
there's another piece, another angle at trying to be compatible with exchanges and a bit more is using those memos for some structure around identity, like consent-based identity when you're interacting with an exchange. So actually, everything you're talking about here is probably super relevant for as like an underlying infrastructure for selecting a format for these things.
Yeah, we do have to think about the multiple proofs issue though.
The combination of what you just said and the point I was making earlier about partial visibility, I suddenly realized there's actually something you can do with our current design that I don't think was intended, but could maybe we want to preserve, which is embedding.
Do you want to say this on a public call, Strat?
Well, it's really more about the structure of this that enables the partial visibility.
Okay, correct.
And it's really the same as like the key duration trees. Essentially, you could imagine having memo trees. So a memo that contains keys for other memos. So that actually lets you, if you have, say, two outputs, one output could be given the ability to view more memo data than the other by having a multi-part memo that contains both the additional data that they want to decrypt and then the memo key for the other. So like Alice and Bob's given a key to view some data, and then Alice is given a key to view some other memo data that includes the key that was given to Bob. So that actually lets you have partial visibility into a memo, which is something that when we first talked about this, we weren't considering was possible. But actually, there's nothing in the structure that prevents you from doing that once you have separable memo chunks. And it wouldn't be something we could avoid anyway in the structure, because it's just the symmetric key, unless we changed how the key changed how the key derivation was done to not be pure symmetric keys.
I think we want it to still be symmetric keys.
Yeah. So actually, this is something that we should.
That's actually important for the post-quantum properties, because if you keep the addresses secret, then because you're mixing the address into destination address into the KDF, and because the encryption based on that the output of the KDF is symmetric. That's what allows it to be post-quantum in that case. So you'd have to be very careful changing that.
Exactly. But the point I was making more is that the memo keys are, at least in the current design, bearer capabilities, essentially. If you can see it, you can use it. And I don't, off the top of my head, have really any better way to do that. Because if you try and avoid pure bearer tokens, then what you end up with is some sort of asymmetric thing that then you have to deal with quantum resistance and whatnot. And I think that's probably too much overhead for what we can do in this stack.
Yeah. I thought of a potential solution to the needing extra proofs thing. If your compliance disclosure protocol thingy, you only need to verify part of the memo per output, then you could just verify that bit, and then it's possible to fit it in a fixed size proof. Or fixed size witness, I guess. Okay. That was quite a comprehensive discussion.
Great. Any other thoughts, comments, questions, or indeed other discussion topics?
I think this is just a really good example of how, I'm really hopeful that that people will think about kind of applications that they need for this kind of functionality, and then work backwards to to what protocol features are or how does that impact the design of protocol features? Because I think even with today's Zcash, there's a lot of unexploited space for using the features that Zcash exposes in novel ways, and so, but this one in particular I'm excited about because it there's just a lot of things that can be done with it.
Great. Paco, you want to say something?
Oh yeah, I think that to tap on what Chris was saying, I think that most of the memo field potentials are not quite exploited yet because we can't rely on an application acting on some memo data that hasn't been authenticated. So like anyone with some common sense would see that it's potentially dangerous to tie some logic of an application to a message that you received that is not authenticated on a blockchain, even though it's to an address and all. Like the feature I was talking about, like using remote configuration and force upgrade for Sashi, for example, or any of the other wallets. Like let's say that we want to deprecate some versions of a wallet, and we could do that instead of like using the typical Firebase kind of remote configuration. We could have the memo be that communication channel without like leaking additional requests to a server or requiring some external library like Firebase that we on the privacy space we don't like much. But again, like if I can decompile the viewing key, I would need to actually see those messages by, I don't know, decompiling the Android or the Swift app. Then I could actually derive the address for that viewing key and start sending messages that are not from the developer. So I could expect the app to lock or something like that. So I guess the authentication is what it really opens up a secure environment to actually make use of memos with more confidence and security.
Yeah, you get that authentication for free in transparent chains because you can observe who the sender is and go and check that it's a sender you expect. Whereas you don't have that capability natively for shielded.
Thank you, Paco. Torche.
Has there been any consideration of setting an expiry time to enable auto pruning?
To enable what?
Auto pruning. So instead of the maybe.
Oh, so that's more. That is more in line with like Zcashd has the concept of running a pruning node, which Bitcoin had, and then Zcashd has somewhat support for it. It's not really well integrated. But yes, you like that was something that I was thinking about when writing up the thing about pruning, is that nodes you could choose to run a node in a way where you can you are still helping the users in the network to be able to send and receive funds, but you can have a lower, a somewhat lower data requirement by not needing to store anything that's stored in the memos as an option, versus a full pruning node like Zcash currently offers, where you just drop old block data, and that's kind of the problem with the shielded piece, in that in the case of a transparent node, you just need to store the latest chain state and you don't need to store the older blocks, and then you can continue appending things. In the shielded case, because all the state is shielded, what state you need to store in order to be able to maintain things going forward is somewhat different. And still, there's certain things like nullifier sets, for instance, which you can't prune. but yes, this is something that a node could opt in, and a node operator could opt into locally auto pruning if they wanted to. Zebra, I think, would have a hard time doing that right now because of the RocksDB, where it's not even you could, I guess, in current Zebra, if that height of auto pruning aligned with the stable height that Zebra was using, so currently 100 blocks, then you could just not serialize the memo data to disk at the same time. But yeah, pruning becomes a lot harder, I think, in Zebra given its current design.
So I think that what Dodger was asking was maybe somewhat different, and I could easily imagine a convention-based approach where, let's say that you add an additional memo chunk that is decryptable by a well-known key, and then use that to contain pruning instructions, for example. So there are ways to approach. I think that the general memo capability and separated memo capability opens up a lot in terms of conventional approaches where you don't necessarily have to bake things into the protocol.
You are still baking that into the protocol, and in fact, doing something like that at the consensus node layer continues the somewhat unfortunate decision that was made with shielded Coinbase, where we baked note encryption into the correctness into the consensus layer.
Yes, and I would like to fix that as part of the memo changes we're doing now. Well, so maybe we can't. I'm not sure.
I don't think we can for shielded Coinbase, but it would extend it to the memos as well.
So if I'm not sure that I agree that, so if you said, okay, the second memo chunk, which is decryptable by the key that is 1 2 3 4 5 or whatever, contains in it a just directive that says the corresponding memo at position whatever, or some in the corresponding memos in this transaction can be pruned after block height X. That's a directive that the node could choose to either follow or reject.
Oh, I see what you mean. So that
would be sort of selective expiry.
That is
purely a conventional option.
Okay, so that is a different thing that I thought that either of you were saying. What this is the equivalent of the transaction expiry, but a memo expiry.
That's what I was thinking.
In the memo bundle. Is that what you were asking about, Dodger, or? Because convention didn't imply that to me, because that's different than actually encoding this publicly in the transaction.
Yes, that's the sort of thing I was suggesting.
Okay, so there is a trade-off there, because if you aren't doing expiry at the entire transaction level, then you're leaking memo data, or rather you're leaking the existence of specific memos. Like the requirement on essentially that would be incompatible with the current requirement about not leaking anything except an upper bound on the length, about the amount of memo data that's present, a combination of the number of chunks and the length of each chunk.
I would be worried about that, because you can imagine that a particular application would be using or needing a particular expiration time, and then you've identified all of the transactions that are associated with that application.
I mean, if expiry for memo chunks, if expiry / pruning for memo chunks happened at the whole transaction level, that might be a level of granularity that seems reasonable, because then the ecosystem would essentially bifurcate into, it's yet another public transaction identifier that we can't get rid of, but it would mean that you would only be bifurcating into expires at some standard heights that wallets agree on to use, or doesn't expire. In the same way that transactions right now bifurcate into, it's not a single bit right now because like for transaction expiry, expiry is at a concrete height, and so it's the delta from whatever the change it was. There is identifiability there. The question essentially then becomes, either, do you couple that to transaction expiry at all, or do you couple the you probably want it to be separate, but the point is, however you encode it, you have to encode a height in some way, which means you could encode any height. So it's not necessarily one bit of information unless wallets appropriately standardize on setting it. But assuming they do that, then yeah, you only have a couple of
I mean, you can make it one bit by making it relative to the expiry height. So say that in order to use this feature, you need to set an expiry height, and then it's either never expire or expire at that height plus some fixed amount.
Right, but then you're trying to make but then you're making an assumption about how long the data is relevant for every transaction.
True.
Which again comes down to what do people want to do with that functionality, and what privacy guarantees does the entire network need to risk for that functionality to be implemented.
Yep, good point. Yeah, I'm quite skeptical because I think that's actually leaking quite a bit of information.
I think there's two things to think about here. Number one is, like, everything's a trade-off. We're targeting perfect privacy. The trade-off is, data being stuck in the blockchain for forever, or at least until
I mean,
until we move to
it's not because it's only if you need it. Right? Nodes can always prune it. Although they would be able to after this change in NU6, because they can just keep a commitment instead.
The other thing that I think we should bear in mind is that in doing this, we are potentially and further entrenching the memo field as something that we're going to rely on in the long term. And I think again, if we look at the long-term direction of Zcash, is that something we want to commit to, or will we find that X years down the line, we're like, crap, I wish we hadn't done that?
Yeah, I mean, something that is not yet specified in there, the fact that we want to be able to encode, there is no memo here, which essentially is the encoding an option of key, means that you also have the ability to encode other kinds of things within the fixed length that is set aside per output. But you could, for instance, encode a key for some off-chain memo, for instance, and then have no memo data on-chain in your transactions.
Yep.
There's nothing fundamentally that prevents that, because at the end of the day, it's a type value tuple going into per note, and particularly given that the memo bundles would be separately counted for fees, it would be entirely possible for people to start not putting memo data on chain at all and instead storing it in some other mechanism with the corresponding questions about data access and reliability and privacy and things, but that essentially would get offloaded to somewhere else.
Yeah, I mean, you could store a Freenet or Toho LAFS CHK, for example, or SSK, so that would give you immutable encrypted files in a DHT, but you would be relying on that DHT for. So if you were accessing it directly, then you might be leaking metadata about that file being interesting to you, so that the transaction with that key must have been to you.
Right. Although we have similar issues with like the light client protocol right now.
Yes.
So, yeah, at least with the current proposal, because we definitely want information hiding for notes in that context. So whatever we use as memo key data there needs to be fixed length. So there is a limit on what you need to either figure out a couple of things, like how much extra data might you require to be able to store a couple of other different kinds of keys in there.
Well, can't you just put that in a memo though? That,
True, actually, you could do the indirection I mentioned before to just have a small memo on chain that then references the memos off chain.
Yeah,
so it wouldn't be removing the memo data fully, and it is still that memo data is subject to prunability, whereas which might be desirable in that case of having the key to the off chain stuff disappear later.
Yes, good point.
Yeah, and again, there's just a big space of options that the fundamental change opens up. There is a small but relevant question, which is given this change, if we're choosing a chunk size, and there are options about whether we're doing chunking or some other kind of padding, would we want to allow the chunk size to drop, say have a chunk size for memos go down to 256 bytes or 128 bytes, and then a conventional memo is 2 or 4 chunks, something like that from a zip 317 perspective. So anyway, just possibilities, overhead versus of chunks versus the requirements for the keys is a piece to be sorted out.
Okay. We have about 11 minutes left. Are there any other discussion topics that we want to talk about?
Dodger said in the chat, out of band note transmission.
That was just a reference to the discussion we were having. Like, that's the name we've used for it elsewhere.
Yeah.
Is it like out of band note transmission more generally was just the entire note data not being stored on chain, and that's partly why we never verified the encryption of the note data. So if people wanted to have like full post-quantum resistance, they could just not put random data on chain, so they can't recover from seed ever, but in exchange they can not have that data stored on chain. And this would essentially be the memo proposal here lets you at least do that for memos. You can choose to just not put memo. You don't even need to pay the cost of the 512 byte field. You just pay the cost of the 32 or 33 or whatever the length ends up being for the memo data thing, and just put either no memo or a link to memo off chain, which is a step in that direction if you want to not have people rely on that.
Yeah, for completeness, Strad obliquely mentioned the length of the Poly1305 authenticator. So Poly1305, it's a 128-bit authenticator, but it actually has security. Let's see, it's 8 times number of 16-byte blocks divided by 2 to the 106, which turns out, if you work it out for a single memo, it's 2 to the minus 98 for Zcash's use. So you might think, is that enough? Because we normally require 2 to the 125 security, but it is enough because it's a different situation to when you are trying to break a symmetric encryption key, because basically you need, in order to break it, you would need the recipient to act as an oracle for whether the authenticator was correct, and so it's an online attack, and that's what makes it infeasible, even though it's 2 to the minus 98. In other words, it doesn't necessarily need to be any longer to resist quantum attacks. But that does need reanalyzing.
Okay, anything else? Let's leave it there then. Thank you so much, everyone, for attending and participating. The next Arborist call will be in 2 weeks on the 16th of May at the later time of 21 UTC. Please check your calendars because it seems there's still some calendar glitches out there. So see you all then. Thank you.
Thank you all. Bye-bye.
Thank you. Bye.
Bye.
Bye, everyone.